Hello, welcome to Flipped. So today we are on covalent bonding, and a covalent bond is formed between nonmetals to achieve noble gas configuration, which you'll recall is either 2, 2, 8, 2, 8, 8, or 2, 8, 8, 18. Okay, so either of these four, that's noble gas configuration. And the tendency for nonmetals is actually to gain electrons, right? Because it's easier to gain a few electrons than to lose all the electrons, okay, as in ionic bonding. But in this case, there are no electron donating metal atoms around. So what do? The best alternative is to share electrons. Okay, and this is how it's being done. It's when the two non-metal atoms come close together and their valence shell overlap. So it's important to take note that only the valence shell overlap and that the inner shells, okay, for example, this is the third shell that we are talking about. The first and second shell do not overlap. Okay, they are still in their individual area. Okay, the electrons still orbit in the individual space. They do not overlap for the first and second shell, but only the valence shell, in this case, for example, the third shell, overlaps. And they must at least share 2 electrons between them. So if they only share like 1 electron, it's not considered a covalent bond. Okay, we'll talk about how many electrons they can share later. Okay, but anyway, this is how a diagram will look like. This is, for example, atom A, this is atom B. Okay, when they form a covalent bond, it's really just this overlapping of space which contains electrons. And with this is a covalent bond. Okay, let's take a look at a few examples. For example, the first one is hydrogen atom. Hydrogen atom, we know that it has 1 valence electron, so it needs 1 more, right, to form the noble gas configuration of just 2. Okay, out of this 4, 2, 8, 2, 8, 8, 2, 8, 8, 18. Okay, so we are aiming for this one because it's the closest to 1, right, 1 valence electron. So what we do is we put 2 hydrogen atoms close together, they will overlap. Okay, so that you see that this electron is on the top, right? So you can just imagine that this hydrogen atom actually just rotates like that. Okay, so that this one faces here, this one faces here. Okay, now they can share the valence electrons with this space here. Okay, we read, now each H atom has 2 valence electrons. Okay, so now we are looking at one individual atom to see whether they have fulfilled the electronic gas configuration. Let's look at this one. Okay, let's do it in pink color. This guy, this pink H, okay, has 2 electrons, right? So it has fulfilled the noble gas configuration. Whereas for this red guy, he has also achieved its stable gas configuration if we just look at the red guy. Okay, so we are talking about individual atom whenever we are talking about covalent bond. Okay, not as the whole molecule, just individual atom to see whether they have achieved the noble gas configuration. Okay, and this is just a repeat. Electrons in the overlapping space, this one, shows that electrons is being shared by the 2 atoms. Okay, this will show you that it's a covalent bond. Okay, next one, let's talk about oxygen. So oxygen, we know that it has 6 valence electrons, right? We are just ignoring the first and second shell. This is just the third shell, okay, which is just made out of 6 electrons. For the first oxygen atom, let's color it that in pink, maybe. Second one, let's do it in blue. Okay, so we can identify them. So that when we combine them, okay, this one is the pink one, this one is the blue one. Alright? Okay, sorry, let's draw it nicer. Okay, so the pink one and the blue one comes close together and they share electrons. But in this case, they share 2 electrons. Okay, because if I just share 1 electron each, it's just 7. Am I right? For example, if I 1, 2, 3, 4, 5, 6, okay, and I just take 1 more electron from this guy, it's not enough, only 7. So what's the best I can do? I have to share 2 electrons, you have to share 2 electrons. And you can see that in this one, okay, after they have shared, the pink one, let's count how many electrons are there. 1, 2, 3, 4, 5, 6 is original, right? Original 6 excess, and 7, 8. Okay, so now the pink one, okay, if you just look at the pink one, okay, ignore the blue one. In this diagram here, it has 8 valence electrons. Whereas for the blue one, it's the same. It's original 6, 1, 2, 3, 4, 5, 6, and additional 2 from the pink atom, 1, 2. So now 6 plus 2 is 8. So individually, okay, the O atoms have 8 valence electrons in its valence shell now, and has achieved noble gas configuration, okay, which is what we want, 8 valence electrons. So it's very important to note that we're talking about the individual atoms and not as the whole, because as the whole, we have how many electrons? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is 12 electrons. It's not in the noble gas configuration that we want, right? We want 8 only. So we are talking about 1 individual atom only. Okay, so with this, we can talk about this thing called bond drawing. Okay, this is usually this is we just want to show the electrons, right? But if we want to do organic chemistry or something, we do not draw dot and cross. We actually do this bond drawing actually. Okay, so from just now, HH becomes H2, right? With a single bond. Whereas for OO becomes O2. Okay, and this one is because there's an X and there's a dot. That means individual atoms just share one electron each to form a single bond. So this one, this symbol just means it's a single bond. Whereas if it's one atom sharing two electrons each, okay, this is a double bond. That means it's a XX dot dot, XX dot dot, okay, as in O2. This one you don't really see, but it's actually, maybe I give you an example. It's actually found in nitrogen, which is N triple bond N. Okay, this means that each individual atom, each N atom shares 3 electrons, whereas this guy also shares 3 electrons to form a triple bond. Okay, but you rarely see this. Mostly we see single bond and double bond. Okay, so this is a more advanced diagram. So what we have here is actually H2O, which is water. So what we have here is we can look at the original O atom. Okay, this is the original one, right? These are its original electrons. So 1, 2, 3, 4, 5, 6. Okay, 6 electrons elects 2 electrons to form the noble gas configuration. What do? Basically, when 2 H atoms come nearby, they form a covalent bond with O. So now they have a single bond each to the O atom, which looks like this in drawing. Okay, and that is all for covalent bonding. Next, we'll talk about the properties and structure of a covalent compound.